रयत शिक्षण संस्था महात्मा गांधी ज्युनियर कॉलेज प्रवरानगर 12th सायन्स फिजिक्स चॅप्टर नंबर 12 इलेक्ट्रोमॅग्नेटिक इंडक्शन लेक्चर नंबर 1. My name Professor N. B. Shetty. Now let us consider the introduction. Now we are familiar with the generation of electric fields by stationary charges and magnetic fields by moving charges. Now scientists overstate Ampere and few others established the fact that electricity and magnetism are interrelated. Now thereafter scientist Faraday performed series of experiments in connection with generation of electric current by means of magnetic flux, and Joseph Henry demonstrated electric currents were indeed produced in closed circuits or coils when subjected to time varying magnetic fields. The outcome of these experiments led to a very basic and important law of electromagnetism, and these are known as Faraday's laws of electromagnetic induction. Now here consider these experiments. Following first experiment, consider bar magnet approaching a closed circuit consisting of a coil and galvanometer G. In this figure, bar magnet is shown. Then coil, which is connected to the two ends are connected to the galvanometer, two ends of the galvanometer, terminals of the galvanometer, and coil has number of turns. Now, in this experiment, when magnet approaches or closed circuit consisting of coil, it produces electric current, and this current is known as induced current. When the magnet is taken away from the circuit, closed circuit, a current is again produced, but this current is in opposite direction with respect to we see in first case. Now, instead of the magnet, the coil is moved towards the magnet or away from the magnet. An induced current is produced in the coil, that is in the closed circuit. Now, when the polarities are changed, or if the polarities approaching the coil when changed, the direction of induced current in the coil is also changed. That means in figure we have shown the south pole of the magnet focusing towards the coil. Now when north pole is focused towards the coil, now the magnitude of induced current depends upon the relative speed of the coil with respect to magnet. It also depends upon the number of turns of the coil. That is, magnitude of induced current inside the coil depending upon two factors, that is relative speed of the coil with respect to magnet, and also depends upon the number of turns of the coil, turns in the coil or that closed coil. The induced current exists so long as there is relative motion between coil and magnet, and therefore here we conclude that induced current is induced inside the coil whenever there is relative motion between the coil and the magnet. Now when we consider the second case or second experiment with the two coils with their planes facing each other, now in this chapter in figure number 12.2, let us consider the experiment. Instead of a magnet and a closed circuit, when we use two coils with their planes facing each other also produce similar effects as mentioned in above experiment, that is coil and magnetic experiment. Now here one coil is connected in series with battery and key and also rheostat, while the ends of the other coil are connected to the galvanometer, and these two coils are placed near each other, and therefore the coil consists of source of EMF is termed as primary coil. In the figure where the battery is connected, we call that coil number 1 as a primary coil, while the other coil which is connected to the galvanometer, that coil we call that coil as secondary coil. With these two coils, following observations are made. Now let us consider what are the observations or what is the experiment. Now first, when the circuit in the primary coil is closed or broken, that means when we press the key or open the key, circuit is closed or broken. Then we see the momentary deflection in the galvanometer at the time of make or break, that is opening the key or closing the key, we see the deflection in the galvanometer. When the circuit is closed or broken, the directions of deflection in the galvanometer are opposite to each other. That is, while closing or opening the key, direction of deflection in the galvanometer, that directions are opposite direction to each other. Now secondly, when there is a relative motion between the two coils, here two coils are at rest and induced current is produced in the secondary coil, but exists so long as there is relative motion between the coils. Now whenever the current in the primary coil is changed by sliding the rheostat jockey, a deflection is produced in the galvanometer. Therefore, by changing the current in the primary coil by using rheostat jockey, deflection in the galvanometer can be changed, and this indicates the presence of induced current. Induced current exists whenever there is change in the current in the primary coil, and therefore an EMF induced in the or induced current in the secondary coil depends upon induced current exists in the primary coil, or when we change the current in the primary coil, induced current in the secondary coil changes, and therefore above observation results that so long as there is a change in magnetic flux inside the coil, and EMF is induced or induced EMF is produced, or in produced EMF is called induced EMF, and direction of induced EMF reverses if instead of increasing flux, the flux decreased or vice versa. That means magnetic flux, whenever there is change in magnetic flux, and EMF is induced in the secondary coil. Now let us consider the Faraday's laws of electromagnetic induction. Now the first law, from this discussion we conclude that, or in first law states that whenever there is change in magnetic flux in a closed circuit, an induced EMF is produced in the circuit. This is the first law, and this is qualitative law of law, since it indicates the characteristics of induced EMF. That means this is nothing but cause of induced EMF, or first law we call that it's cause of induced EMF, or qualitative law, or first law. Now second law, Faraday's second law states that magnitude of induced EMF, or this production of induced EMF, is directly proportional to rate of change of magnetic flux linked with the circuit, and this law is quantitative law, since magnitude of induced EMF is given, or this law gives the magnitude of induced EMF, and therefore first law is qualitative law, second law is quantitative law, or we say that first law gives cause of induced EMF and second law gives magnitude of induced EMF. Now let us consider phi is the magnetic flux, E equal to Here phi is magnetic flux at instant t, then the induced EMF is directly proportional to rate of change of magnetic flux. Here solving the equation, proportionality side taken, k is proportionally constant, as E phi and T are constant measured in the same unit system of unit, k equal to 1, therefore E equal to d phi by dt. If we combine the expressions with the first law, E equal to minus d phi by dt. Now flux, phi is flux with single turn. If we consider the number of turns as n for that coil, then phi equal to number of turns into phi dash, and therefore E equal to minus n d phi dash by dt. This is also known as E equal to minus n d phi dash by dt. This is also known as flux rule, according to which EMF is equal to rate at which magnetic flux through a conducting circuit is changing. E is measured in volt and d phi by dt measured in Weber per second.
Thank you.
Thank you.